Hello everyone. I'm Pradeep, software related and fintech. Today, I, along with Amrit, will be presenting these many words on listing and how can we go about design listings platform. Over to you, Amrit.
Hi everyone, I'm Amrit, and I work as a tech lead here at Flipkart, and we'll be looking at some of the deeper aspects of how listings is modeled here at Flipkart and some of the challenges we've come across.
Sure. We will be starting with this. As I explained, we'll be discussing about the listings platform, right? So, just to go through the agenda, we'll be talking about what are listings so that, we set that context first. And then, we will be also checking with the evolution, also, along with the Flipkart, what challenges we faced in the listings domain, right? Then we will be also going to what was the desired state we approached, what was our approach in reaching to that desired state, and the Q&A we will be taking. So as simply as put, right, I'll just be sharing this screen, and then whatever you buy is a listing, right? So as simple as that, just from the buyer's perspective, right? You land on the Flipkart website and then you start shopping, you add to cart, buy now, all these are happening at a listings level, right? So this is the buyer's perspective. I'll also be sharing the seller's perspective, where seller onboards to our platform, how they share these they create these listings, right? So if I am a seller and I want to sell a Redmi Note 5 product, I need to onboard to seller dashboard, seller platform. I'll also be giving my intents to just to take these examples like MRP, what is the selling price. There are many attributes, but for simplicity, like MRP, selling price, what is the stock I have. All those details are given by a seller. Right. So after those the things are captured, we capture it and send it to downstream systems, and that's how buyers see these listings on the Flipkart. To simply put, but there are many systems in between. Like there's a search angle to it, there's a pricing angle to it. Right? Like I said, there is an instrument to specify price and inventory part, which we just discussed, and everything mostly is pivoted on listings, where the inventory is based on listings, the orders which you create is listings, and then other things as well. This was just to set the context. What is listing for buyer and seller? We'll be also moving to evolution of Flipkart as multi marketplaces. What is marketplace? To simply put, there as well, it's like a bazaar. You go in Sabzi Mandi or you go to a grocery shop, right? For with the picture, this is a seller, there are some of the customers, and these are the products. So these grocery shops are like bazaars, and we also have these where I'll be talking about grocery, supermart, and all. So marketplace enables those sellers to connect with the customers, and different marketplaces fulfill different needs. We'll be also talking about this key, how does it matter, right? So a bit of historic context: in 2015 there was only one marketplace, which was Flipkart. As and when consumer needs were there, we started evolving it into multiple marketplaces, call it bazaars, where there is a construct of consumer need where we want quick delivery. This is like 30 minutes, 1 hour kind of delivery. Then supermarket is for grocery, where slotted deliveries for your day-to-day needs are there. And Flipkart Shopsy we have recently launched, which is social e-commerce platform. There's a Flipkart wholesale also, which is mostly B2B, where large sellers buys it from our platforms. How these marketplace differs in between is, one is volume of listings and how many transactions it will be, right? So that is one differentiator across these marketplaces. Second is the business models. As you can see, these are business to customers, and these are B2B, where we are selling it to large businesses. They can buy it in bulk, the Flipkart wholesale part. And there are different policies also around it, the validations, what should be the return, what should be the commission rate across these marketplaces. We'll be talking about policies in detail, so just bear with me for a few minutes. So as and when these marketplaces were being added in Flipkart, right, it was getting evolved. And in starting, it was only single Flipkart marketplace. and the schema, whenever we started adding refurbished business was one, grocery business was second. So all these schemas looked like same, where all the attributes and all the things were kind of same. So we started latching on to the same shared schema where all the attributes were same, as you can see in this picture also for Flipkart and Supermart. But as and when business needs started coming, just to give an example of the business need in, let's say, grocery, vegetables, right? Or like Surf Excel is there, there will be lots to it. There'll be some expiry dates attached to it. Let's say next month something is getting expired, that lot we need to ship it first, so that there are no issues, and then later, like if it is, the expiry date is next year, that can be shipped later. So those constructs came in grocery. Shared schema, we face that challenge because of shared schema, where lots is meaningful for grocery, but let's say for mobile kind of construct, the lots will not make sense. But for the shared schema, we had to add these lots attribute there as well, as a empty or default lots to support the downstreams, right? The issue with that was that there is no particular schema which is tied to a single marketplace. It is scattered all across. Everything is optional mostly, because anything can be this selling price, let's for an example, will be mandatory in Flipkart, versus just an example, selling price can be optional. So that way, we with the shared schema we'll have to make it optional. Other challenges were the business validation policies. We have taken an example where if it is a Flipkart, return policy has to be this, grocery no return, or in that case, other cases it should be 10 return. So just to set that context also, in the starting it was all same, all these return policies were exactly same, or very minute differences. But as and when requirements started coming and business needs, these started evolving it like this, right? And the issue with these kind of if else or shared policies is, if we are changing for Flipkart, it has potential to break other marketplaces. So these are also shared validations. Other angle to it is resource utilization. These numbers are for illustration purposes. In grocery, let's say we are getting the scale for 4x, but for Flipkart week it is only 0.7x, right? But the scale which or the requests which are coming to grocery, those can affect other marketplaces because it is a shared resources. So that was also another challenge. So overall, we discussed schema was a challenge because it was shared. Policy validations were also challenged because it was shared, because you have to change, and it can potentially break all the other things, and the resources were also challenged. So what we aspired it to be after that, right? So the aspiration was to break that single large complex domain which we had previously into smaller independently evolvable subdomains. Other thing was, like in this picture you can see, right, the multi-tenant angle to it. So in this picture, if you take grocery and Flipkart, which we had taken before, there is a schema tied to it separately where it can evolve individually. So now it is not tied to other marketplaces where these schemas can evolve independently, and there is no default logic here. Policies are very straightforward, where you can only define it for Supermart or for Flipkart itself, and these can also be independently evolvable. Multi-tenant is where you have different pipelines for processing, for storage, all those things, they do not interfere with each other. So that was the aspirations which we had. Like I mentioned, right, each tenant should have a different configurable schema, policy, and resource provisioning, so that it is decoupled in a way. It doesn't affect between marketplaces. And other thing was key, where we'll also be talking about, where these attributes which were there, it was a flat data bag, and we have grouped it together, like pricing attributes can go to price facet. So anyways, Amrit will be talking about the facets, so I'll just skip for it, just wait for that to happen. So our approach, Amrit will be talking about. Over to you.
Our approaches, and we'll be looking at some of the more specific aspects of the approach that we took. Starting with data modeling principles. So data modeling was actually one of our core concerns, as Pradeep very clearly outlined. We had an issue with shared schemas and shared policies, business rules, that is. And so this was one of the core pain points, I would say, right? And so that was a good starting point for us. And uh, the what how we approached it was to actually logically group those attributes which form a listing, right? Aspects like price, selling price, and like MRP, etc., would be grouped into a logical sort of a facet called a price facet. And similarly, you can have an identity facet, you can have an inventory facet, and so on. And the key kind of uh, goal out of doing that was to also be able to organize your business policies on top of these facets. As generally, policies actually control multiple attributes, right? And not just individual attributes. For example, selling price should always be lower than or equal to your MRP. At the same time, your attributes can vary across pivots, such as location. Your amount of inventory can vary across the different locations. Your selling price may differ across locations. So, we have an example here where for the Bangalore location, we have a different selling price. And a faceted listing is a logical model that we have over here, which is enforced by a notion of a schema. We also took into account versioning of the schema, so that we're able to read back data, which is mutated at a different point in time, and the schema has since evolved. So evolution is a core construct. And having a schema, a logical schema, which is separate from the physical schema, is also an important aspect for us. This allows us to kind of optimize for the right storage mechanism that we want. For example, we could encode the schema as Avro protobuf, regardless of the logical model that we choose. Um, the other aspect that we wanted to get into was to actually decompose our domain in by functional and non-functional domains. That is, your functional domains and your generic domains. And the way we wanted to go with that was to actually look at the responsibility boundaries. So, single responsibility as one of the core tenets for actually figuring out what are the functional boundaries. So this is what we came up with. So we have a listing definition domain, which essentially talks about schema, and how to version those schemas, enforce those schemas. We extracted business policies into the policy domain. We extracted, the life cycle of the entity, the listing entity, into the life cycle domain, and so on. And these are supported by a variety of generic domains. And generic domains are technical domains. They help the flow, uh, uh, help us complete the flow, right? Um, and if you look at all of these, they're independently evolvable, independently scalable, and most importantly, we had to involve a variety of stakeholders, right? So we had to understand, the business counterpart, operations team, the product and tech teams, build common vocabularies, and these are important to actually avoid miscommunications, to have a single meaning for uh, each of these terms. So, what do you mean by policy? What do you mean by schema? What do you mean by listing? Right? And share this across, evangelize this, use those specific terms. And this avoids miscommunications. This helps you come up with a better domain model, right? Uh, Two challenges primarily, and one of the challenges that we faced was actually regarding orchestrating the flow of a listing, or the listings life cycle or request life cycle through these domains. Uh, so what we needed was something that looks like this. You have a listing request, a listing request that comes into the system. This is containing seller specified information such as what Pradeep had mentioned, such as price, your inventory levels, other selling information, shipping charges, etc. Uh, Goes through an amount of enrichments. So this is internal, external, NDI level enrichments, which are to validate the content of the request. So are the shipping charges valid? Is the price correct? Things like that, right? And on success, we go for persistence. On success, we publish it, right, to interested parties. In case any of these steps fail, we would like to retry it for a certain amount of time, with exponential backoff, etc. And we also want to have observability through this pipeline. So if I submit a request, I want to be able to, what is the outcome of validation? What stage in this pipeline is the listing request at? Right? And we have to do this at scale. So we have to do this at 100 million executions per day, right? Of such workflows, right? We have a limited number of such workflows, such as enrichment, validation, persist. We may have a workflow which just does enrichment and validation, and so on. But they're fairly simple, and a key characteristic is that they are um, unidirectional. So you don't have a step that goes from persistence to enrichment and so on, right? Um, and we need these steps to be strictly ordered. That is, persistence happens after validation, publish happens after persistence, right? So these were some of the requirements that we required. And what we had previously was a choreography based model. And if you look at what choreography is, it is essentially an event driven system whereby an event triggers, you can call it a trigger event, triggers a particular process. That process may produce certain outputs or certain output events which may go certain other processes, right? And this is generally a very flexible model, so you don't have a really well-defined formal definition of what this flow could be. You cannot really have good trackability or visualization of such a, right? It would be up to each business, and you may have to have interceptors at each level to even build something quite expensive. Um, and the other thing is, you cannot promise that your flows actually get completed, right, to your client. So if this was a listing upsert sort of a request flow, if let's say if a seller updates their listing, you cannot really give them, an end-to-end view of your inventory is updated, that your listing is visible, etc. Retry, timeouts, failure handling gets very complicated because at each stage you may have a different strategy to implement. You need to make sure that they're consistently implemented. You're going to have additional logic at various other levels, right? What does orchestration solve? Orchestration actually solves for most of the problems that are there with choreography above. However, it introduces a new component, and that is a central component, right? So we have a data here, and that data would look at actually completing enrichment, completing validation, completing persistence, and uh, that works for our kind of use case, right? So what this allows us to do is actually make sure that we can actually guarantee that these steps are done. We can actually promise an SLA and so on. But it does come at that cost that there is a center. You need to make sure it's highly available. And so we chose a hybrid approach that combines the best of both, right? Uh, so what we did was we made the observability aspects, the external notifications aspect of this process. For example, we need to notify that enrichment is complete or validation is complete. Those are sync, right? Um, and essentially, we just have the orchestrator to babysit this particular process, right? And uh, in order to make it uh, available, or let's say what happens, the auction fails at the validation step, right? We're going to make sure that we can resume it from this step and we don't repeat the whole step, right? So that was the ordering concern that we had to fulfill. And for that, we had to make sure that we're actually in progress, right? The that go and the outs of these processes are actually stored in a durable manner and can be resumed. Um, Retry handling, failure handling gets easier because you can control what to do at each stage and you can express that in a consistent manner. So we had a few tech choices that we considered, and these were the tech choices that we had at the time. And we considered Cadence, which is by Uber, ZB, activity, and we considered quite a lot of pivots, and these were some of the pivots that we thought were quite important. Finally, beyond some of the tech choices, we also considered some of the pragmatic choices. Right? We looked at the maturity. We looked at the deployment complexity of the architectures that these bring. We looked at the adoption ease and available in-house expertise. We looked at support for scale-out persistence. Again, we're talking about hundreds of millions of executions potentially, right? We also looked at whether we're able to visualize the process in some way. So that was the observability pivot. Um, and so we actually ended up going with Apache Camel, and that was a choice. Uber Cadence was a good contender. However, it brings about a lot of stateful components. It did not really have uh, the kind of adoption in Flipkart at the time, and I think that stands true today as well. Next, we'll be looking at another interesting challenge, which was to do with the listings lifecycle. So, I think Amadi in his talk also mentioned, uh, how entity life cycles are fairly straightforward, and for us, the natural modeling was actually a state machine as a machine. So many use cases actually can be modeled as a state machine. Many use cases can be defined as being in a finite number of states, and one state at a time. And state machine is basically a concept that helps us manage how to move between the states, so you have a consistent outcome. And in a nutshell, it's basically this: you have a current state and add an action or a transition or an event, and you get a new state. So we can take an example of a simple circuit with a light bulb. So you have a switch which can go on and off, and if you press the switch, it may or may not turn on the light bulb, depending on what is the internal state of that particular circuit. Right? If the switch was in on position, the light would have been on. Turning on the switch would turn it off. Right? Um, and so a listing entity lifecycle is a very similar to model from a domain perspective. And there's a simplified view of it. A listing can be active and inactive, and it can toggle between these states. And once it's deleted, you can't really get back to those states, right? Now imagine we have to do this for a billion such entities, right? So what are the challenges and some of the solutions we looked at? right? So in terms of challenges, so if we had to make sure that it is scalable, what is the solution that we come up with, and what we came up with was something which is inventory. Uh, at the application layer, it's horizontally scalable with horizontally scalable persistence as well. And uh, The implementation choice that we went with was a Spring State Machine, and that's primarily because we're in a Spring Boot based stack. There are a few good options in the Java world. However, this is quite a mature uh, implementation. Um, Now, how did we actually go about storing the state machines? So it is essentially one state machine per record, like one row equals one state machine in HBase, and during the lifecycle of a request, we would actually go and read it back, bring it in memory, play the events, and store it. Um, I hear you talk about concurrency, right? What happens if you get multiple requests, right, for the same entity? So how do we go about solving it? There are a bunch of ways you can talk about making sure this is a mutual exclusive lock, right? So that only one app instance actually operates on the state machine. However, this being a distributed system can be difficult to achieve. So we also implemented something called multi-version concurrency controls. Each of these state machines are actually versioned, and we reject uh, updates on older versions of the state machine. How do you make sure that state machines are reliable, right? Um, State machines reliability is very an important aspect because you don't want to miss out on, let's say, active transitions. If you have a listing that the seller requested to make active and you lose that event, that's going to be a bad outcome, right? So how do we guarantee reliability of the effective state? So for that, we actually went with the CDC or the change data capture system, right, which would work on the events incoming into the state machine. So this gives us a couple of advantages. One is that we have we can actually guarantee that we act on all of the states, all of the transitions that come in, and we also have some amount of replayability if we choose to, right? So we can play back events in case of a disaster scenario, etc., and restore it. So we have several advantages in this architecture. One is that you have horizontal scalability on your application as well as on your data layer. And another thing we would just like to touch upon is around migration. This is a system which has been in existence for a long time, and migration is a huge endeavor, right? So we have close to a billion across seven marketplaces, a lot of different interconnecting policies, and so there is really no way you can do that in a big bang approach, right? So we went with an incremental migration, a few sellers at a time, let's say marketplace at a time, a few categories at a time. And this came with the challenge that you had to keep both the old and the new systems running, right? So we did things like shadow traffic replication or traffic replication, automated anomaly detection and reporting, and supplementing that with bulk migration, right? And so this was a approach that helped us actually transition into this new system. And the learning basically was that the last 10%, right, that you would normally get for migration actually can take up quite some time, right? So automation is something we are recommending. And this is the final state that we arrived at. So we have an ingress layer, which is essentially our API gateway, which does things like admission filters, locking concurrency, control quality of service, service orchestration layer, which executes our workflow. We have a core stateless multi-tenant application layer and our layer. Again, this can be replicated across for every marketplace that we have, for new marketplaces that come up, and it runs in a cloud native sort of environment. Cool. So we'll pause now for any Q&A. Pradeep, would you like to also join? Great. So I think Q&A we can take up in the breakout room.